When people say they downloaded a model, what did they actually download? Because in my head, a model is kind of an app you launch, and I get the feeling that's totally wrong.
It's completely wrong, and that's the most useful misunderstanding to clear up. A model isn't a program at all. It's a folder of files that just sits there, doing nothing, until you bring something that knows how to run it.
Okay, so if I open that folder, what am I looking at?
Three things, really. The weights, which are the billions of numbers the model learned. A config, which is the blueprint that says how to wire those numbers together. And a tokenizer, which is the piece that turns your text into something the model can do math on.
Start with the weights. Those are the famous billions of parameters everyone quotes.
Exactly. Every fact and pattern and bit of grammar the model picked up is baked into those numbers. They're usually stored in a format called safetensors, which is just a safe, fast way to hold a giant grid of numbers on disk. By themselves, they're meaningless. A billion numbers with no instructions.
And that's where the config comes in. The instructions?
Right. The config is a small text file that describes the architecture, how many layers there are, how wide they are, how the numbers flow from one layer to the next. Without it, the runtime has no idea how to arrange those billions of weights into a working network.
And the third piece, the tokenizer, that's the one I understand least.
The tokenizer is the translator between human text and model math. It's a fixed vocabulary of text chunks, plus the rules for splitting any sentence into those chunks. And this is the part people miss. The tokenizer has to match the weights exactly, because the model learned its numbers against that specific vocabulary.
Let's actually walk that translation. I type a sentence, what happens step by step?
First, the tokenizer chops your sentence into tokens, chunks that are often whole words, but sometimes pieces, like splitting unhappiness into un, happy, and ness. A token is roughly 3/4 of a word on average.
But the model doesn't see the word un. It needs numbers, right?
Right. Each token has a fixed ID number, its slot in the vocabulary. So your sentence becomes a list of integers. Then each of those IDs gets looked up and turned into a vector, a long list of numbers that captures the token's meaning. And that's finally something the model can multiply and add its way through.
And on the way out, it just reverses.
Exactly. The model predicts the next token as an ID number. The tokenizer decodes that ID back into text, and it repeats one token at a time until the answer is complete. That whole loop is why the tokenizer matters just as much as the weights.
So that explains why I can download some models and not others. What are the actual flavors of access here?
The most common open kind is open weight. The lab publishes the weights, the config, and the tokenizer, so you can download all three, run the model on your own machine, and even fine-tune it. You hold the actual model in your hands.
And open source is something stricter than that?
Much stricter and much rarer. Fully open source means they also release the training code and the training data, the entire recipe to rebuild the model from scratch. Most models you'll hear called open are really just open weight. They give you the cake, not the recipe.
And then the big commercial assistants. Those are the closed ones.
Right, with a closed model, you never touch the weights at all. You send your text over the internet to the lab servers through an API, and the answer comes back. You're renting the capability, not holding the model. Most of the very best models work this way.
So say I've got an open weight model downloaded. What do I actually need to make it produce text? It's not just double click and go.
You need the three files we covered, plus two things you bring yourself. First, a runtime, an engine that loads the weights and does the math. Common ones are Hugging Face Transformers, the VLLM engine for servers, and llama.cpp or ollama for running on your own laptop.
And the second thing is the hardware. This is where the memory math from our earlier episodes bites, right?
Exactly. The whole model has to fit in memory. So you want a GPU with enough room, or a regular CPU for small ones, and there's a trick that makes this realistic at home. Quantization shrinks the weight files by storing each number in fewer bits, often packaged in a format called gguf, so a model drops onto consumer hardware.
So if I had to keep one sentence in my head, what is a model?
A model isn't software you just launch. It's weights plus a matching tokenizer plus a config, and you supply the runtime and the hardware. Once that clicks, the whole open versus closed debate and the question of what you can actually run yourself suddenly makes sense.